So, imagine this. You've just flown 500,000 miles to the moon and back. The journey's almost over, but the last 30 minutes, that's the single most dangerous part of the entire mission. We're going to dive into the incredible engineering challenge of bringing the Artemis II astronauts home safely through Earth's fiery atmosphere. For the astronauts, the mission isn't a success until they are floating safely in the ocean. Just listen to Artemis II pilot Victor Glover. He says that final moment, the splashdown, has been on his mind from the very beginning. It just goes to show, for all the excitement of flying to the moon, the most critical part is sticking the landing. And here's why. It all boils down to one single mind-boggling number. The Orion capsule is going to slam into the top of our atmosphere at nearly 25,000 miles per hour. That is 30 times the speed of sound. All of that speed, all of that energy has to go somewhere. And where it goes is into pure scorching heat. Yeah, this final part of the flight is an absolute gauntlet. As the capsule plows through the air, it compresses it so violently that it creates a sheath of plasma reaching almost 5,000 degrees Fahrenheit. We're talking about half as hot as the surface of the sun. The only thing standing between the crew and that inferno is the heat shield. And get this, there's no backup. And that is exactly why test flights are so incredibly important. The uncrewed Artemis I mission, it was a huge success. But after NASA fished the capsule out of the ocean, they found something they totally weren't expecting, a critical lesson that absolutely had to be learned before putting people on board. So here's the heat shield before its big trip, looking absolutely perfect. It's made of this amazing material called Avcoat, and its job is literally to burn away, to char and slake off in a very specific controlled manner, carrying all that intense heat away with it. It's a proven system for sure, but a return from the moon like this was going to be its toughest test yet. Everything depended on it working exactly as the engineers planned. And here's what it looked like when it got back. Now, what you're seeing isn't just a bit of normal scorching. Instead of burning away nice and evenly, entire chunks of the material had just broken off. You can see some serious erosion around the bolts. This was not in the script. The models did not predict this at all. And it wasn't just one little spot either. A deep dive inspection found over 100 places where the material had worn away in this unexpected way. So let's be clear, NASA had a massive engineering puzzle on its hands, and the clock for the first crewed Artemis flight was officially ticking. Now, the heat shield for Artemis II was already built, so a total redesign was just not an option. So what do? Well, the engineers got to work. They took this really methodical approach. First, figure out the root cause, then run a ton of ground tests, and finally, work out how to fly the mission safely with the hardware they already had. They basically decided if they couldn't change the shield, they would change the reentry itself. And this right here is the brilliant solution. Okay, so Artemis, I used this really complex skip reentry. It kind of dipped into the atmosphere, used its own lift to bounce back out into space for a bit, and then came down for the final plunge. It turns out that maneuver created some crazy pressure spikes that tore up the shield. So for Artemis II, they're using a much simpler lofted reentry, just one gentle single arc that completely avoids those extreme conditions and spends less time in the hottest part of the ride. And this just shows you the new game plan perfectly. You can see the whole mission laid out, but the really key part is that final step, entry, descent, and landing. It's now a more direct, much more controlled path that's been specifically designed to give the heat shield an easier ride home. And look, this wasn't just some theory they cooked up. As Debbie Korth, who's the Orion Deputy Program Manager at NASA, said, this new plan was backed by a huge ground testing campaign. They basically blasted samples of the heat shield to simulate the new reentry conditions over and over again to prove this new approach would keep the crew safe. But crew safety is never, ever about just one system. It's a whole philosophy of having layers of defense. Yeah, the heat shield is the first line of defense against that crazy reentry heat, but it's just one piece of a much larger safety net designed to manage all the risks of deep space travel. Let's talk about radiation. Once you leave Earth's protective magnetic bubble, it's a real hazard. This chart puts the dose for Artemis II into perspective. It's about double what the average person gets just living on Earth for a year. It's a known risk, but it's well within the career safety limits NASA sets for its astronauts, and it's something they monitor constantly. At the very heart of engineering for spaceflight is this concept called redundancy. It's a fancy word for a really simple, powerful idea. Always have a backup,
And if you can, have a backup for your backup. You just have to assume that things might fail, so you build a system that can handle it. And the parachute system is the perfect example. Orion has a total of 11 parachutes that all fire off in this precise sequence. It's the 3 huge main chutes that slow the capsule down from over 300 miles an hour to a gentle 20 miles an hour for splashdown. And here's the amazing part. NASA has actually tested the system by pretending one of the main parachutes failed to open, and it still landed the capsule safely. That right there is redundancy in action. So, after all the years of analysis, all the testing, all the tweaks, the final and really the most important check is the confidence of the actual people whose lives are on the line. This quote from NASA's Amit Chatria just nails it. It really captures the immense amount of trust that's required for this kind of work. The engineers provide the data, they provide the analysis, but at the end of the day, the crew has to have complete and total faith in everything they've done. And there it is. That's the confidence you're looking for, and it's coming straight from the mission commander himself. Reid Wiseman makes it crystal clear. He trusts the engineering, he gets the problem, he gets the solution, and he is ready to go.
And here they are. Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. Everything we've been talking about, the physics, the materials, the orbital mechanics, it all comes down to one thing, making sure these 4 explorers get home safely to tell the world their story.
So, when you think about it, the Artemis I heat shield issue wasn't really a failure, was it? It was priceless data. It was a problem that, once they solved it, made the entire program safer and a whole lot smarter. It really makes you wonder, as we start pushing farther out from the moon onto Mars, what other problems are just waiting out there for us to discover and solve, making every single journey safer than the last?